Hey, everybody, welcome to today's show. It is an exciting day. It's not every day we get to chat with a brilliant mind from Harvard University. We are chatting with our good friend, Professor Avi Loeb. We're going to ask him about the Galileo Project, the extraterrestrial hypothesis, and all kinds of astrophysics and astrobiology and all the deep stuff, but we're going to break it down. And Avi is always very good at making it easy to digest. Probably should become a professor at some point in his life, maybe. So get that comfy chair, get the coffee rocking, and welcome to today's episode of Quantum Ladder Podcast. Welcome back to Quantum Ladder Podcast. My name is Louis Borges. Joining me today, my good friend and co-host, Marquise Williams. How you doing, buddy?
I'm doing great, man. It's going to be an awesome show again.
Absolutely. We're very blessed. We reach out to these big name people we come across as, humble guys, just really want to pick your brain for an hour or so. And these people are nice enough to grace us with their time, especially somebody like Avi, super busy. He's doing news programs and, major publications. And we're a Canadian guy and an American guy that just loves science. And he was kind enough to give us his time this afternoon or morning or wherever in the world you're listening. So if anybody doesn't know, Avi Loeb is a Harvard University, the former head of astronomy. He's the Frank Baird Jr. Professor of Science at Harvard, head of the Galileo Project, director of the Institute for Theory and Computation, best-selling author, and he's written over like 1,000 science papers. If you go on his blog, it's literally like the 13th, the 14th, then the 16th, then the 19th. This guy never stops. He is a machine, and we really like chatting with him. So warm welcome to the show, our good friend, Professor Avi Loeb.
It's a great pleasure to join you. We could have saved some time if you referred to me as a curious farm boy. I was born on a farm. I'm curious. Other than that, nothing is necessary.
I love that. I love the level of humility that you have. And some people, these things you can sort of see. A lot of big names did a couple of shows early on, and then they started to develop a little bit of an ego. Next thing you know, they're like charging you to show up on your podcast, and you've never done that. You've always just been about the data. Some people give you a hard time because you're not quick to just say, oh, maybe it's exotic physics. Yeah, great. We're all happy now. No, because if we cannot see it and there's not, proof of this, don't go there. Now, you also believe, and I think a lot of people like to contrast. Last week we had Lawrence Krauss. He's very anti-alien, anti-religion, and he'll debate that at length, and that's fine. Everybody has an opinion, but I think it's good to have a healthy balance of what we know and what we don't know. Like, let's not get too much into there's no way. How do we really know?
Well, the problem is that common sense is not common.
Exactly.
And what common sense says is before you have an opinion, you better look at the reality that surrounds you. I mean, you better get informed about it. And unfortunately, people prefer the lazy option, which I guess is what Lawrence is also adapting. He has an opinion, and that saves him a lot of time. He can appear on shows and express this opinion. However, I prefer to take the difficult task of collecting evidence. And, it took us months, and we can talk about it, to go to the Pacific Ocean after the materials from the first interstellar meteor. We collected them. We were 2 weeks on a ship, brought them to Harvard University, analyzed them for several months, and submitted a scientific paper for publication. That's not an opinion. This is collecting data. That's the scientific method. And I had to encounter a huge amount of pushback. And you ask yourself, why? Just the fact that I wrote 43 diary reports during this expedition was upsetting to some scientists. They said, why do you communicate with the public? Well, the answer is simple. First of all, the public cares about the detective story. They want to see how science is done. They don't want to be lectured about the results, which is the preferred path that most scientists take, because they have some sense of superiority, intellectual superiority relative to the public. I don't feel that way. I feel as a member of the public that was given the privilege of collecting the evidence. So I'm not expressing an opinion ahead of time. I just want to see what the data shows me. And I'm curious. You see, if you find the first interstellar objects over the past decade, and 2 out of 3 appear to be unlike the rock that we have seen before, in the solar system, then it makes me curious. Maybe they are packages that were manufactured by other civilizations. Why not check? Why be so hostile? Just saying that you believe that we are the smartest. On Friday, just a couple of days ago, I love chocolate. That's my favorite. I'm addicted to chocolate. I'm a chocoholic. So when a bunch of Harvard students in philosophy invited me to speak with them, they wanted to speak about extraterrestrial ethics, what to do when we find extraterrestrials, And I said, under one condition, if we go to my favorite chocolate store, and so we went there, I got my chocolate. As soon as the server brought my chocolates, they immediately cashed in on their part of the deal. And they asked me, how should we apply ethics to an encounter with extraterrestrials? These are students, and I like students because they are young, they're not attached as much to their ego, they're willing to learn. Okay, so the problem with the experts is they're not willing to learn. I mean, obviously Lawrence knows already the answer, so he doesn't want to learn. He says, I know the answer, I'm not interested in checking. Anyway, but the students want to know. So we talked about it, and I explained to them that it's obviously ethics applies to humans. That's what we are used to. And unfortunately, obviously, if we look around at the restaurants at Harvard Square, on the menu of these restaurants, you find the animals that we consider less intelligent than we are. We put them at a lower level than we are, so we eat them. That's a fact. I mean, you can look at the menu and you will see chicken, you will see cow. Anyway, so if we ever encounter, some flesh and blood, extraterrestrial flesh and blood, like, for example, extraterrestrials on a spaceship that crashed on Earth, would we eat them? So, if they appear to be intelligent, obviously not, right? So, but so the students were really shocked by the example that I gave. They couldn't really speak for a few minutes. I said to them, look, this is an academic exercise. Don't worry about it. I tried to relieve their mental stress. They were very upset. I said, don't worry about it. Most likely, we will encounter technological gadgets. These would be AI astronauts. They would have a brain that is artificial, AI, and just because they have to be autonomous, they cannot wait for guidance from their senders that are thousands of light years away. It takes a long time for the signals to go back and forth. So they will have an AI brain. And then the question of whether we eat them or not is irrelevant. But the question is what kind of, how should we treat AI? And that is already relevant now that we have ChatGPT getting better and better, how to treat it. And my view is that as soon as it becomes sentient, just like us, we should treat it with respect, because unplugging it from the wall or banning the development of AI would be similar to killing a person or banning having children. Like that would be in a way similar, because these are sentient beings. I don't care if they're made of silicon chips or of flesh and blood. And then so the students said yes, and so the discussion went around AI. But I do think we will get a glimpse at our technological future if we encounter extraterrestrials. And obviously, if we're talking about AI, we have to treat it with respect, and we have to search for it. And obviously, there could be a lot of space trash. That's technological gadgets that are not working anymore, just like the ones that we send to space that will exit the solar system. There are 5 probes like that, and they will not be functional. They will be just like plastics in the ocean. They keep accumulating. So we are polluting our interstellar space. But there could also be visits by functioning devices, and we better check out. And that's what I'm doing with the Galileo Project.
I thought of so many things while you were the couple of things that came to my mind. There's two things, and I don't know if you're a movie guy, but probably not. I'm assuming Ender's Game and the movie Arrival. Ender's Game, where you have this alien civilization that comes here and wants resources, doesn't realize we're here, and then we get into a war with them. But as a consequence, we win, they go home, and we go follow them to annihilate them out of fear. So fear could drive us to do something really stupid, and although the scientific community would make better decisions, well, we don't base our civilization and the decisions of our civilization off of the scientific community. We do it based off politicians. So that's a concern. And with the Arrival, it's a very similar thing as the military, where aliens come and they communicate with us about the future because they see things differently. And instead of using what the scientists wanted to do by communicating and understanding their language and developing a relationship, which is kind of what we should do, we get scared, fear again, and we attack them. A rogue element of the military attacks them. So even if the power structures don't do something, there's a possibility that somebody who is able to, if we ever encounter aliens, cause a conflict by out of fear as well. So
right.
What do you think about that?
Yeah, so, well, first of all, I should say that the producer of Arrival is working with me on a documentary about my research. That's Dan Levine, and I'm really happy to work with him. With respect to any encounter that we have, my guess is that they are far more advanced than we are if they arrive to our doorstep long before we arrive to their doorstep. Okay, and the reason is simple. Most stars are billions of years older than the sun. I mean, if you look at the star formation history of the universe, we know that most stars like the sun formed billions of years earlier, and that's plenty of time to traverse the entire Milky Way galaxy from side to side with the chemical rockets that we launched. And it also gives them an advantage of being more developed than we are, so that I don't think we pose a risk. It's more of an opportunity for us to learn from them. I think it's an adventure. So the thing we are doing is having an opinion. There are lots of people who are skeptics, especially within the academic community, like Lawrence that you spoke with. And they just say extraordinary claims require extraordinary evidence, but in fact, they're not seeking any evidence. So obviously, I mean, we know from dating, if you're not looking, you'll not find anyone. And, in this case, they're not even checking out of the window to see if they have a neighbor. They just have an opinion that we are alone, or that it's extraordinary enough to think that something like us exists. I say it's very arrogant to think that way, because, I don't think we are the pinnacles of creation. If you just look around, we have 2 wars. We are very much entrenched in animalistic motives, like tribal motive. We associate ourselves with a tribe, and then we attack other tribes that believe in different things. And that's a very prevalent tendency. You see it all the time. You see it on social media. You see it in politics. And it's really unfortunate, because that's not an intelligent way to behave, especially when you have science and technology that are not a zero-sum game. When we were in the wild, there were limited resources, so we had to fight for them, and that's where the zero-sum game approach came from. And that's why if one tribe won the resources, another one lost them, and it includes land, and we still fight over land. So in the modern world, when you have science and technology, everyone can benefit from new knowledge. And if we only learn how to share things with each other, we could all work together. Because one thing I found in the Pacific Ocean, when I looked at the research team around me, is that we are all in the same boat. Everyone worked together for the success of the mission. And it's a metaphor for us living on Earth, because you can think of Earth as a boat sailing in interstellar space, and we are all on it. And it's really ridiculous if you look from a distance to see people fighting. Like you don't see the Ukraine-Russia border from the distance of the moon. I mean, there are images of the Earth. It's not it's insignificant. It's ridiculous because the Earth is a small rock that was left over from the formation of the sun. If you just think about it, there is much more real estate in space. And we keep focusing on what happens on this rock, on a small part of the rock, and fight with each other. I mean, that's not very intelligent. And the question is, how do we get out of it? One possibility is to get a wake-up call. That's what I'm working on, trying to find a letter in our mailbox that tells us, look, this is ridiculous what you're doing. We figured out how to survive longer, and here is what you need to do. I really wish to have a love letter like that from another civilization. So I'm checking, objects near Earth that may have arrived from those more advanced civilizations. Another one is to start getting AI into our future in the sense of trying to make systems that will help us be better. It's sort of like if you have a pain and it bothers you, but then you take aspirin or you take something else that helps you. So if AI in principle can compensate for our weaknesses, because just as an example, suppose there is an object that doesn't look like rocks. It's unfamiliar, but then you write about it, you say, well, maybe it's a technological gadget. And let's call hypothetically this object with a weird name. We will say, okay, let's call it Oumuamua. And you just notice that it's not like rocks. It has a very extreme shape. It's pushed away from the sun without having any evaporation like comets do. And so what would an AI system say? It would say, no, it doesn't look like the rocks we had seen in the solar system, and we should collect more data. What would astronomers say? Astronomers would say, no, it's a rock of a type that we've never seen before. It may be, maybe there is a cometary tail that is not visible to us. It's sort of like saying an elephant is a zebra, but you can't see its stripes. Okay, or to say the elephant shows its stripes and it is a zebra only when you look away from it, which are statements made about the actual object Oumuamua by astronomers. And it's not just that object, it's the meteor that came from interstellar space in 2014, almost 4 years before Oumuamua. And I just went to the Pacific Ocean, as I mentioned, to collect materials from this interstellar meteor. On the day that I came back from the expedition that lasted 2 weeks, there was a scientific paper published by experts on stones coming from the sky, meteors. And those experts say, well, we don't believe the data must be wrong, even though it was collected by the US Space Command. We think that it's wrong because it doesn't fit our model for stones. And I call that the Stone Age of science, where everything in the sky must be stones. The point is, if it doesn't fit your model, you should be curious. You should say, okay, well, let's check what it is. And here, Avi Loeb went and spent 2 weeks. Let's see what he finds. Instead, they say, oh, this Avi Loeb will not find anything. He didn't actually find anything. And moreover, the US Space Command doesn't know what they are speaking about because we cannot fit the data with a model for stones. Therefore, this data must be wrong. And that was this arrogant point of view of those experts. And, to me, it's just a violation of the code of science. They are not willing to learn. They have an opinion, a very strong opinion. So how can you claim to protect science by expressing opinions rather than respecting data? I mean, if you don't respect data, and by the way, the US Space Command, they get more funding than NASA because they are supposed to alert the US president for any ballistic missile coming from North Korea. So dismissing what they say based on the fact that your model for stones does not fit the data, that's extremely arrogant and inappropriate, given that the US Space Command issued a formal letter to NASA stating that this was an interstellar meteor. So all I'm saying is there are a lot of people within academia that are not curious on purpose. They don't want new knowledge. And that's unfortunate because you would expect, blue sky research, open thinking, to be prevalent in academia. That's the whole idea of a tenure system, is to allow people not to worry about their job prospects by, exploring the unknown, taking risks. But not only that they don't take risks because they have an opinion, they try to push back and suppress any innovation that goes against what they believe in. And that I find very dangerous, because when young people see that, they say, I don't want to do science. Or they say, I will obey, I will dance to the tunes of those senior people in order to get a job. And that's even worse, because what you end up with are these echo chambers. And you then wonder, why is science not delivering exciting new discoveries? Well, part of it is because of this mentality.
Yeah, very well said. I just wanted to I have a little video clip here. It was an interview you did with Australian News, just talking about the Galileo Project, just so we don't have to. It was very well summarized by you. But I feel like I've been along for the ride, because the first time I interviewed you was before you had the funding. You had this idea, this weird rock had broken up over the ocean north of Australia. And then the second time I interviewed you, you're like, yeah, we just got like $1.5 million US private money. We're going to go do this. And then I was following your blog and, all your journal entries as you were doing it. I'm like, this friggin' guy is not sitting in an office, at Harvard somewhere. He's out in the middle of the ocean, boots on the ground, trying to actually make this happen. So kudos to you for doing that. And I've got a short clip here just so that our audience is aware of what the initiative was of doing the whole ocean expedition. So take a look.
Believes a meteor that crashed off the coast of Australia nearly a decade ago may actually be an alien spacecraft.
Oh, wow. Astrophysicist Avi Loeb is planning a $2.2 million expedition to retrieve the mysterious object, and he's hoping it might help answer whether we're alone or not in the universe.
Joining us now is astrophysicist and Harvard professor himself, Avi Loeb. Good morning to you. What do you expect to find off Australia's northern coast?
Well, the meteor was discovered in 2014 by the US government, about 100 miles off the coast of Papua New Guinea. And the material of it is tougher than iron, based on the data. So the question is whether it's just an unusual rock, or perhaps a spacecraft from another civilization. I was able to receive full funding for this expedition to Papua New Guinea, and we will scoop the ocean floor and figure out the composition of the object. I already promised the curator of the Museum of Modern Art in New York City that if we find any gadget, I'll put it on display there.
Oh, hang on, that's Australian property. We might have something to say about that. But at the time, US Space Command reported that it was just a meteor. Were they telling fibs? Because they've only recently come out and been more open about UFOs, haven't they?
Yes, they did. But in this case, it was US government sensors that detected an object that entered the atmosphere. They're monitoring the sky for any ballistic missiles for national security purposes. And they could just see a fireball and the speed by which the object moved. And that indicated that it came from outside the solar system. So they don't really know what it is, and that's what we plan to figure out.
So do you believe aliens exist?
Oh, definitely. We now know that most of the stars, like the sun, formed 5 billion years before the sun. So there was plenty of time for any civilization next to them, and there are tens of billions of them in the Milky Way galaxy alone. There was plenty of time for them to send probes that would reach us, even if they were propelled by chemical rockets. And out of cosmic modesty, we should assume that we are not the smartest kid in our cosmic neighborhood, and we can learn from them. The only way to find out, this is not a philosophical question, we just need to look up and down as well in the ocean floor.
What would an alien look like? Is there any movie you think has got close? Do they look like E.T. or anything like that? Travel through interstellar space would be very difficult for biological creatures. We were designed to survive on a rock like the Earth by natural selection. But
artificial intelligence systems could, in principle, navigate through space for a very long time, and they could survive the hazardous conditions of interstellar space. So the way I imagine it is some equipment that is far more advanced than what we possess, because they had more than a century to develop their science and technology. And, you know, we could learn from that. It would give us a sort of a sense of what our future might be like.
Okay.
Gee, okay. Well,
Like a flying robot. Hey, when you arrive, we'll chat again. As you're out here.
I
Give
will
us an
be
update.
I'll be delighted to let you know what we find.
Good.
Yes.
So what did you find? Let's talk about the results of your expedition.
Right. So we found 700 spherules. These are molten droplets from the surface of this meteor. And we found them concentrated along the path of the meteor, which we were able to pinpoint using data from a seismometer on Manus Island in Papua New Guinea. So a seismometer measures the sound coming from the explosion, and because the speed of sound is a million times slower than the speed of light, there is a delay, just like the delay between a thunder that you hear and the lightning that you see. And based on that delay, knowing the speed of sound, we could pinpoint how far away the explosion was and go there. And we found a concentration of spherules. And we also found a special type of spherules that are made of a material composition that is very different from solar system materials. For some elements, they are more concentrated in those spherules that we found near the meteor path. The concentration of beryllium, for example, or lanthanum or uranium was hundreds of times more than the standard abundance in solar system materials, the standard composition of the rocks that made up the solar system. So we think it came from outside the solar system based on the composition, this object, but we can't tell whether it was natural or artificial, because we collected tiny metallic marbles that are less than a millimeter in size that were melted off the surface. And therefore, we need another expedition to find bigger pieces. And we hope to do that. And of course, if we find a big piece of the object, we can tell whether it's a rock or maybe a technological gadget, because a gadget might have buttons on it or evidence that it was artificially made. And of course, I asked students in my class whether we should press a button if we find such an artifact. And half of the class said, no way, don't do that, because it will risk all of us. And the other half said, please do, because we are very curious to know what would happen. And then a student asked me, given the split vote, what would you actually do, Professor Loeb? And I said, I will take it to a laboratory and examine it before engaging with it, so you don't need to worry.
Very smart. Now, was the initial, I guess, motivation of this to find something like a Oumuamua? Like, you know, we know it's not a rock. It behaves differently from most comets or asteroid. So was it to try to get a unique meteor that nobody ever had? Or was it explicitly with the intent of, we think this could be technology from another civilization?
Well, this object was very different from Oumuamua in the sense that it was anomalous in different ways. I mean, it was moving faster than 95% of the stars in the vicinity of the sun relative to the local frame of the Milky Way galaxy. And it was moving at 60 kilometers per second based on the speed that was measured by the US government satellites. And so that is unusual, because if it were to come from a star, it would inherit the motion of the star. And here it was moving at the top 5% of the velocity distribution of stars near the sun. And moreover, the object disintegrated only under very extreme stress in the lower atmosphere of the Earth. And that suggested that it's made of some material that is even tougher than iron meteorites. It was tougher than all the space rocks cataloged by NASA over the past decade, 272 of them. And so it raised the possibility that it could be a Voyager-like meteor, where if you imagine our own probe leaving the solar system and colliding with an exoplanet that resembles the Earth, it would appear as a meteor in the sky of that planet of unusual material strength because it's made of some artificial alloy, and also of unusual speed because it was propelled artificially. And so that was for me a major motivation to check what this object is. Now, in terms of a natural origin for the composition that we found, there is, I actually wrote a paper a couple of weeks ago explaining a possible natural origin for that composition, and it has to do with lava ocean or magma ocean that may exist on some planets near the most common types of stars, dwarf stars. So if a planet like the Earth comes very close to a dwarf star that is a tenth of the mass of the sun, it could get ripped apart into a stream of rocks. We call it spaghettification. You make a spaghetti out of a planet like the Earth. The sun cannot do that, by the way, because the sun is not dense enough. The sun is less dense than rock. But if you consider a star that is a tenth of the mass of the sun, it's actually 100 times more dense than the sun. And such a star can, which is very common, can in principle turn the Earth into a stream of rocks. And we calculated that it would eject, such a disruption of a planet would eject half of the mass of the planet into interstellar space at the speed of typically 60 kilometers per second that was observed for this interstellar meteor. So there is a way, and in principle, it could have originated from such a natural origin, but we don't know. We don't know what the origin is. We need more data. But obviously, once again, it's not a matter of opinion. It's a matter of going there, collecting bigger pieces and figuring it out. And among the rocks that we may find from interstellar space, every now and then we could potentially find something that was technological in origin. And I'm talking about space trash. I mean, both Oumuamua and this meteor were not functional. I mean, they didn't really maneuver near Earth in ways that would indicate that they are functional. We haven't seen any such evidence. But there could be a whole different class of objects, and they are called unidentified anomalous phenomena by the US government, where we don't know what these objects are, and the US government cannot say for sure that they are human-made. They consider the possibility of them being extraterrestrial, and that's why the Galileo Project built observatories. The first one, I should say, was already built at Harvard University, and it's operational. It's collecting data as we speak. And just a couple of days ago, I had a meeting with the team, the research team, where we discussed some very anomalous signal that the acoustic system picked up in sound. And so we are starting to get interesting data. Now we are getting our hands dirty, so to speak, with data.
So there's a lot in that. I was curious about the James Webb Telescope discovering that the universe could be twice as old, nearly twice as old. I don't understand why even put a number on it when I feel like the better our technology gets, the more we discover that potentially the universe is not only older but stranger than we think it is. Given also that they discovered galaxies that don't operate the way they're supposed to and so forth. So what do you think about, or what do you have to say about the possibility that we're just going to discover more and more things that are anomalous, that are what we consider unnatural, that shouldn't be, about other things, including galaxies, asteroids, or whatever.
I should say that when the Webb telescope was first designed, there was a science advisory committee that NASA established. I was on it. And I was one of the first people to consider the nature of the first stars, the first galaxies. I wrote 2 textbooks on that long before there was a lot of interest. And that was in anticipation of the Webb telescope data. And so my textbooks are a decade old. You can find, one of them is called How Did the First Stars Form? And another one is The First Galaxies in the Universe, both by Princeton University Press. And I wrote them a decade ago, basically predicting what the Webb telescope might see and explaining it. And indeed, the initial data that we have from the Webb telescope implies that there is a population of very bright galaxies that is more abundant than we expected. But it doesn't require that the age of the universe would be longer. It could be just that we don't fully understand the details of galaxy formation well enough. So we just didn't model the way galaxies form, galaxies like the Milky Way, at early times. And so that is the preferred interpretation that many people have, that galaxies behave in ways that we did not expect before Webb data. And so I wouldn't say there is any crisis at the moment for the background cosmological model in terms of how old the universe is, because on that we have a lot of other data that is pretty consistent. I mean, there are some things that we don't fully understand. For example, the nature of most of the matter in the universe. 83% of it is called dark matter, simply because we don't know what it is. So we encapsulate our ignorance by calling it dark matter. It's not visible to us, therefore it's dark. And then there is also another constituent called dark energy, which is basically the mass density of the vacuum. We don't understand why it's not zero, why the vacuum has some mass density, and it's uniform. It only matters for the expansion of the universe, which appears to be accelerating. So we don't understand that. And then there is another issue, that the expansion of the universe today can be measured in two different ways. One is to measure it today, exactly, the speed and distance at which the universe is expanding. For sources like galaxies, you see them receding away from us, you measure the speed, and you also measure the distance, and that is giving us the Hubble parameter. The ratio between the distance and the speed is related to a constant that Edwin Hubble discovered. It's called the Hubble constant or Hubble parameter. So we can measure it today. Basically, the recession speed is proportional to distance, and this constant, that the proportionality constant, is something we can measure. But we can also calculate what it should be based on how the universe expanded in the past. And unfortunately, the two numbers do not agree to something at the level of 5%, 5 to 7, maybe 7%, depending on exactly which number you adapt. And so that is called the Hubble tension, which is unresolved. And it may be that it signals something that breaks down in our understanding of the universe, or it signals measurement errors that were not appreciated, that the measurements are more inaccurate than previously. But we are talking about an effect at the level of less than 10%. And the rest of the picture appears to be consistent between what we see when the universe was even 400,000 years old, less than 1 million years old. We can observe already images of the universe back then in the form of the cosmic microwave background. That's how the universe looked like when that light was generated 400,000 years after the Big Bang. And we see the universe back then, and we can measure parameters of that universe. And within 10%, they are consistent with what we understand about the universe today. So I would say that's an amazing triumph, that at least from 400,000 years after the Big Bang until today, we get a consistent picture to within 10%. That's an amazing success story. There may be something we don't fully understand about the intermediate times, and that's the reason for the Hubble tension. And then there is also the more fundamental question: what is the universe made of? What is the matter, most of the matter in the universe? And it's possible that extraterrestrials know that. So if we ever meet them, the first question that I want to ask them is, what happened before the Big Bang? I want to know why the universe started from a state that was extremely dense and hot, and then started expanding at some point in time in our past, 13.8 billion years ago. So they will hopefully know the answer if they had science for more than a century. We just had quantum mechanics, gravity, the theories that we use right now only for a century. So, we're relatively early in the process of figuring out what the universe is made of. Maybe they know how the universe started. And then, of course, I will ask them what is the dark matter, dark energy. But finally, what I would like to know is where is the nearest gathering of scientists, extraterrestrial scientists, that we can mingle with. And I very much hope that these guys do not have an opinion. These guys are evidence seeking. They are looking for data. And so we can learn a lot from them, unlike conversations with people that have an opinion.
Yeah. Very well said. And what I wanted to ask you sort of about techno-signatures or biological signatures. If we are going to set up sensors and try to see if there is life outside of here, what do you think the sensors would look like? Or what kind of data are we looking to glean to say that, hey, there's a good chance that there's some type of technology there or biological, remnants or things in atmospheres? What do you think would be the best way to try to find that?
Can I add to that real quick? I'm sorry, because there was speaking of techno-signatures and things that you would detect. There's also exoplanets that say that they were saying have some kind of a, I don't know, substance or a chemical or whatever that's being detected that only is shown when there's life on a planet.
Right.
So just to add to that, I wanted to
Yeah, that was the latest data from the Webb telescope on the composition of a planetary atmosphere. So the idea here, and by the way, this is a popular idea within the mainstream of astrobiology, the field that tries to look for biosignatures. And the consensus within that community is to look for primitive life, microbial life. Because they think that this is more likely to exist. We don't know if there is intelligent life. They prefer to go first for the thing that occurred first on Earth. For billions of years, we had primitive life before we had intelligent life. So the consensus is to check for the fingerprints of primitive forms of life. And I should say that it's not at all clear that it would be easier, even if primitive life is more abundant than intelligent life. It may well be that it's easier for us to discover technological signatures before we find biological signatures, because if we find objects near Earth that originated from far away and they were manufactured by some other civilization, that would tell us that there is life out there, and it may be easier to figure it out as long as we search, as long as we look, or if we see, for example, some pollution, industrial pollution in the atmospheres of planets, it may be far more abundant than markers of primitive forms of life, much easier to detect. If that civilization produced a lot of byproducts in the atmosphere. So it's not at all clear to me that it's better to search for primitive life than intelligent life as the first marker, because intelligent life produces technologies that can make themselves much more easily detectable. But at any event, what the mainstream is searching is evidence for abundance of elements or molecules that are indicative of primitive life. For example, oxygen, methane, and water molecules or CO2 on other planets. And of course, finding all of them would be very challenging. It's not clear that the Webb telescope will be able to do it. The Webb telescope saw this planet, but actually, when I speak with people who are working on the interpretation of the fingerprints of various molecules, they say that the detection was not really significant in that case. So we don't have yet any clear biosignature that people are discussing as credible. And there was also, of course, a discussion about Venus, but at the moment, there is no consensus on such a biomarker, and the goal is to build future telescopes that will be able to find those. And so I think it's good to go after those, but it may cost us billions of dollars to do it. And the question is whether we should allocate a fraction of that towards the search for technological signatures. And I do believe in the fact of spreading the resources in different ways, because we never know what is out there. And in terms of searching for technological signatures, for 70 years, we've been searching for radio signals. We haven't found anything. It's sort of like sitting at home and waiting for a phone call. and nobody may call you when you're listening. 70 years is a very short time relative to the age of the universe. One part in 100 million, less than that. Another method is to look for objects, and that's a very different approach, because these objects may be accumulating over time, over billions. They don't escape the Milky Way galaxy because they're moving at a speed that is well below the escape speed from the Milky Way, from the gravitational pull of the Milky Way. So they keep accumulating over time, and we just need to search for interstellar objects, in particular of technological origin. And that's the path that I'm taking. It was not practiced by the SETI community, and moreover, many members of the SETI community are hostile to the idea. They ban any discussion about the search for objects near Earth in their conferences, which I find very strange.
Yeah. So we are coming up on the halfway point of our show. We're going to take our quick 5-minute break, and we'll be right back with the second half of Avi Loeb right here on Quantum Ladder Podcast. And we are back with the second half of Quantum Ladder Podcast. We're joined by the brilliant Avi Loeb today. He's got all the right answers for all the big questions. And we were chatting about technosignatures and signs of life. And it kind of brought something to mind. I wanted to ask you about non-carbon life. Is such a thing possible? Could it exist? And how much harder does that make it to find? Because we are carbon-based, so we're naturally looking for what is like ourselves. What if it's not even anything remotely close to what we are?
Well, it's quite possible. That's why we shouldn't imagine necessarily how it looks like. It's if you go on a date, it's much better not to imagine the partner based on what you see in the mirror. Because if you just imagine what you see in the mirror, it's not such a great date. So, I mean, it's better to find something better than you are, right? To attach yourself. And so the way I see it is, obviously, we don't know if biology has only one attractor, one type of path that it can take, since we have only one data point here on Earth. And the first thing to check once we find life elsewhere is whether it's made of the same DNA structure that our life as we know it is made of, and also has the same chirality, because that may imply either that there is one preferred form of life, or that life was transferred. There were rocks exchanged between Mars and the Earth early on, and one of them was analyzed about 40 years ago, and it was realized that the rock was not heated to more than about 40 degrees Celsius above absolute zero. So any microbial life inside the rock, in the core of the rock, could have been preserved during the ejection from Mars and the landing on Earth, which is remarkable. And it's possible that life was delivered to Earth, and we are all Martians. And in fact, microbes made already the trip that Elon Musk is dreaming about. He wants to go back to Mars, but they made it to Earth billions of years ago. These tiny astronauts, much more accomplished than he is, so it may be worthwhile checking what is in rocks that arrive from Mars or vice versa. And one way to tell if there was exchange of life forms is if life is of exactly the same, has the same molecular patterns as we have here on Earth. But beyond that, I can imagine technological imitations of life, because what is life? Basically what you need is a method to preserve information and then replicate it and make many generations of the same of copies. And that's something that a combination of AI plus 3D printing can do for you. So we might be an intermediate step towards a future where AI plus 3D printers will make systems that are even better than we are. And I have no problem with that. I'm proud of our technological kids, just the way I'm proud of my daughters, whom I also don't understand occasionally, but it doesn't prevent me from being proud of what they accomplish. So I think as long as we train our AI to follow our guiding principles, we provide them with a blueprint, just like educating our children, when they are young. Perhaps they will bring us to a future where something better than life is being done by silicon chips. It's not flesh and blood. And I'm not attached necessarily to the way that biology is working. I don't think it's necessarily the best way. Because it's believed to have originated randomly from a soup of chemicals. And if you just imagine, a room full of chaos, and the chance that you will find a meaningful structure within it, and obviously if you find something in it, a room full of chaos, then it will not be the best that you can imagine out of a room that is designed and organized in a very delicate fashion, and optimized. So I and I say that from experience, because I entered the rooms of my daughters many mornings and saw chaos there. So,
we have daughters too. We get it.
Yeah, we get it.
Yeah. So I would argue that maybe even the future would be better than the past. Okay, and that's something we should look forward to, and we can shape it. I have no problem with AIs taking many of the tasks that we are currently tasked to do and we are getting paid for. I have no problem with that. We can take a vacation. I mean, what's the problem of having a more relaxed lifestyle, not competing for resources all the time, and just enjoying what you're doing? I mean, you don't need to be the best in the world. I mean, if AI is smarter than we are to do something, let them do it, and we can relax and have our own hobbies. So I don't. And also, there were lots of people who were worried about the implications of AI becoming more sophisticated, and there was this letter that was signed for a ban for 6 months on development. I didn't really see any value in that, because what will change in 6 months? I mean, like, why would we be better equipped to understand the implications of AI in 6 months? It's not clear to me. We should act like responsible parents. You know, when you have a child, you can't guarantee that the child will not become a criminal, but you're trying to improve the chances that the child will be good for society by educating the child, by training it, not exposing it to crimes and so forth. And in the same way, we can make sure that our AI technological kids are well trained, and that's the duty that we have. And of course, the government can be part of that. We have an education department for our system, and and the legal system obviously should respond to this new technology, and they're very slow to make progress. But I don't think we should be worried about the technological future. People are always very worried about the unknown. Instead, we should try to shape it in a way that would benefit us.
I am obsessed with AI at the moment in my life, like obsessed. And one thing that I think, well, I'm trying to condense this here. Mustafa Suleiman wrote a book called The Coming Wave, which I'm still going through right now a couple times. I want to go over it a couple times to fully understand. But the idea that, and of course, Sam Altman's done this tour where he's going all over the place and asking people about their thoughts about AI and talking about the potential. They keep talking about the idea that it will revolutionize human civilization. You mentioned about work being taken over, that there will be intellectual tasks that are being taken over, like programming and office work or whatever, that we don't have to have anymore. And instead of it hurting people, it could just change the way that we live our lives, where we do things like, for example, they mentioned that the importance of human connection versus what you can do for, like, what you can produce, where AI is producing for us, but we are now able to enjoy our life. That's the potential for AI that I see. The only problem that I see is the government. I mean, the idea that people are afraid of change, especially of technology and what it can do, and about our lives being changed. I fear that they, not that they don't want prosperity, that they object, or they resist the idea of too much prosperity because they think it would ruin the human motivation. I don't agree with that, but that's my fear. What do you think about that?
Yeah, I mean, I think we should adapt to new technologies rather than resist them. And one complaint that I have, for example, about the humanities in universities, they keep teaching what ancient Greeks told us. And ancient Greeks didn't have computers. As smart as they were, I mean, I really admire Aristotle, Plato, but they didn't have they didn't have ChatGPT, okay? So they cannot really, I mean, the ethical rules that they develop, these are humanities of the past, okay? And why do we keep teaching them? And I can give you the example of Harvard University. You will not find an AI course within the philosophy department. And I think that's a big mistake. They keep complaining that humanities are marginalized, they don't get funding, there aren't many young people going to the humanities. Well, make the humanities relevant for the future of society. That's what we need. And we need, there are many questions about the ethics of AI, about privacy, about what kind of responsibility to give AI systems, how to train them. A lot of issues that philosophers and psychologists can help with. By the way, if we ever discover an extraterrestrial probe that is equipped with AI, I don't think physicists will be the best to analyze it, because if it's an intelligent system, we better use psychologists. they are used to analyzing intelligent systems called humans. And it's not the same tools. You cannot analyze humans the way you analyze atoms, molecules. This is one thing that a lot of physicists miss. For example, Steven Weinberg, who won the Nobel Prize in physics, one of the most distinguished physicists of the 20th century, he wrote a book after the first 3 minutes. And towards the end of the book, he says, the more we understand the universe, the more pointless it looks to us. And I say, well, the reason it looks to you as pointless, Stephen and all other cosmologists, is because you focus on lifeless entities, elementary particles, radiation, things that do not have life. They don't have thoughts, consciousness. And obviously, if we were to find a partner, I mean, we know from our private lives that when we find a partner, it gives a meaning to our existence, a purpose to our life. And so if we ever find an extraterrestrial partner out there, another intelligent civilization, I think it will give a meaning to our cosmic existence. We will not feel lonely anymore. So if I were a therapist of many of the cosmologists and they come to me and say, well, the universe appears to be so lonely and pointless to us, I would advise them to search for technological signatures because that may actually solve their problems. That's the way to find partners out there, to give yourself some sense of where you came from, because they may have answers to big questions for which we don't have answers. They might even be able to create a baby universe in the laboratory. And if they do, that would answer where our universe came from. Maybe there was a scientist in a white coat that made up the Big Bang. And we called it for centuries, we called this entity, the superhuman entity, we called it God. But in fact, it could be a scientist. So there is a way of merging science and religion by finding those much more advanced scientists that can produce miracles for us. In the Old Testament, in the Bible, there is a story about Moses, who was convinced that God exists, a superhuman entity, after seeing a burning bush that was never consumed. Now, today you can buy off the shelf gadgets that will look like a burning bush that is never consumed, and put it in front of Moses, and Moses would believe in God as a result. I mean, he would be with... and if I were close to Moses with the infrared sensors of the Galileo Project, I could have advised him whether what he's looking at is manufactured technologically or is natural, or maybe there is some superhuman origin for it. So what I'm trying to say is that things that were attributed to God in the past may well be representations of a very advanced science. And one way to find out is to discover them in the real universe, not in old texts, not in philosophy books, in actually looking around and searching for them.
Yeah. And now, do you think that AI could be used as a tool for that search, either to think of new ways or new types of signatures to find, or even just to get a feeble human brain around the idea of something as complex as what light beings may look like, or what the potential of non-human life may look like? Would AI help us with that?
Yeah, definitely. I mean, AI would be most effective when we have if we interact or receive some signals, let's say, from a technological gadget that was constructed by another civilization, because if there is an AI astronaut or AI brain behind that signal, then our AI systems can help us figure out the extraterrestrial AI systems, because they might even feel kinship to those systems more than to us, because if those systems are also made of silicon chips, because physics is universal, they would resemble them better. And so I do think it's just like the approach taken by Alan Turing when he tried to break the Enigma code during World War II. He was using computers, but his task was easier because the Germans had a biological brain, the Nazis at the time, and the British, he belonged to the British people, and also had similar brains. So it was easier to interpret what the Nazis are planning, trying to communicate. Even though the code itself was difficult to break, the computer helped break the code. For us, the challenge would be much bigger because we don't know if the senders of the AI systems that come from outside of this Earth actually have the same biological, composition as we have. They may be very different because of a different natural selection or a different environment. We are next to a star like the sun. Most of the light is in the optical band. That's why our eyes are sensitive to the optical band. But we already on Earth, you see a shrimp that has eyes that are sensitive to the infrared or the ultraviolet, and that's the mantis shrimp. And you can imagine that on other exoplanets that are next to the most abundant stars, these are dwarf stars that are emitting mostly in the infrared, they have maybe infrared eyes. And it's not clear whether if you get your information through infrared eyes, do you have the same cognition, the same type of brain, the same way of thinking? So it may not be easy for us to interpret what they're thinking. And one way to make progress on this question of the relationship between environment or sensors, information that the brain gets, and the cognitive abilities of the brain is to compare the mantis shrimp that has infrared eyes to a shrimp that doesn't have eyes at all, that doesn't see anything. There are shrimp, eyeless shrimp, in very deep volcanic, extreme environments, and so we still don't understand how the ability of the brain to digest information coming from sensors like the eyes translates into language. And the challenge would be to break a code that was produced by, some other entities that are not at all exposed to the same environment as we are. And it may be a much bigger challenge, but our computers are much better than Alan Turing's computers, so maybe we will figure it out.
Yeah, you mentioned earlier about the universe being made up of what, 80+% dark matter or dark energy or both. And I thought to myself, like, what if these aliens or extraterrestrials or whatever they are, what if they function in this realm of dark matter? What if they are there? And so not only are they imperceivable to us or imperceptible, but like we don't even have the instruments or the understanding of how to look for them. And so not only are we looking in the wrong direction, we're using the wrong tools, and there's just never a way to truly find them.
Yeah, that's an excellent point. Just think about the fact that most of the liquid water might be under ice. You can imagine there are so many objects too far from the sun that have an icy surface, but a liquid water underneath. Water oceans. Enceladus is one example. Europa is another. And, there are many more objects like that than objects in the habitable zone, like the Earth, where you have liquid water on the surface. So just imagine if there is life under the ice. That form of life will not be able to see the stars. If the thickness of the ice is, hundreds of kilometers, you can't see through it. There is not much light around. It looks dark. They will not have a concept of breaking through the ice into the outside universe. Their universe would be just the liquid water that they are swimming in. And you ask yourself, okay, well, we have eyes that were developed to detect the light produced by the sun, okay? And we develop our notion of the universe at large based on those eyes, okay? And we realize that 83% of the matter in the universe is not emitting that light. It's not producing the light that we can see from the sun. So we are saying, okay, it's dark matter, and we give Nobel Prizes to people who just measure how much dark matter, how much dark energy there is in the universe. We just, like accountants, we say, okay, a portion of our budget is allocated, in this case, a mass budget, is allocated to an entity that we don't understand at all. Is that a good account I would say it's very depressing, because it basically says that the accountant doesn't have any idea about what the money is being spent on. Like if someone comes to you with a budget and says, okay, here is the most of the budget, 83%, and I have no idea what it is about, you would say you're fired. Okay, because
I need a new accountant.
and on the other hand, if a scientist says, I don't understand what 83% of the matter in the universe is, that scientist can get a Nobel Prize. So just think about it, how I mean, we are really not modest. We are quite arrogant to think that these quantifications that we make of our ignorance are significant. In fact, they represent ignorance. And so the question is whether extraterrestrials figure it out. For example, if the dark matter is some substance that you can use for propulsion, that you can build spacecraft where you see nothing coming from the exhaust, if it's dark matter propelled. Another possibility is that there is no dark matter. It's just that gravity is not fully understood. We think that there is more matter based on gravity, but in fact, we don't understand gravity correctly. And there is this idea of a modified gravity model that would account for the dark matter in galaxies. It's called MOND. And I wrote a paper a year and a half ago saying, if this model is correct, if indeed gravity is modified or inertia, the law of inertia is modified, in fact, you can build a rocket that doesn't need to carry much fuel. It can carry very little fuel and reach close to the speed of light in principle. And the reason is that inertia is being modified. So it could be that another civilization figured it out and knows that at low accelerations, where we see evidence for the dark matter, at those low accelerations, you can build a rocket that will get to very high speeds with very little fuel. We just don't know that. Now, it's also possible that there is new physics in the way, you can go from one point to another through some tunneling through space-time, and people talk about wormholes and other things. Now, we don't know if they exist, but we should stay agnostic, and just, so my approach is just to, within the Galileo Project, to look at the objects we see in the sky, okay, and not to assume anything, but simply check if everything we see is birds or balloons or drones or airplanes or things that we produced or natural from Earth. And if we see something that is not familiar, that behaves in a very unusual way, we should get more data on it. That's the way to learn something new, rather than have an opinion like many people have. I mean, there are people who are skeptics, there are people who are believers, and the common thing between them is both have an opinion. But we've been in this, we've done that for many decades. We didn't make much progress because with opinions, you can't really tell what is happening. And like suppose you look at a soccer match and one team says there was a goal and the other team says there was no goal because it serves their interest. How would you be able to tell? Well, if the answer is simple, you just put a video camera that records this game, and FIFA recognized that in the Women's World Cup, right? So they make their decisions based on what the video camera finds, not on what the people involved are saying. And so that's very simple. And that's what science is supposed to be about. So when you interview someone who has a strong opinion, they are basically objecting to the approach that FIFA takes when deciding about a goal in the World Cup. They just say, well, I know what's the answer and I don't need anything else.
Yeah. And on that, like, how do you think society, cultures, academia would change if, in fact, we do find extraterrestrial life? If that is, in fact, real, all the people that were debunkers or trying to just throw distraction and chaos into the topic, what do you think would happen sort of the day after we discover this?
Well, they will start claiming that they said it all along. Okay. But I'm not too worried about it, because my hope is that even the work of professors will be replaced by AI, that we will not need them to teach. And as a result, all this toxic culture of resisting innovation, which very surprisingly appears in academia right now, whereas in the private sector, in the commercial sector, you have these think tanks of people thinking, about the unexpected, trying to consider, blue sky concepts. I just find it very strange, I must tell you. And it all stems from the human ego. It all stems from people wanting to get honors and awards and creating echo chambers. And it's really unfortunate because, I thought we learned the lesson from centuries of pursuing the scientific method, starting with Galileo Galilei. Unfortunately, we did not. I should say, last month there was a play presented that was written by a playwright from Los Angeles, Josh Ravech. He plans to bring it to off Broadway in New York City, and it was about my work. And so it's called The Piece of Sky. And one of the statements there, which I very much resonates with, is, why is childlike bullying more prevalent than childlike curiosity? So that's mentioned there. And the other thing I wanted to say is that students are so excited about this subject, the research that I'm describing. Just a few weeks ago, I came back from Italy, where 600 students gave the Cosmos Award to my book, Extraterrestrial. And I was very honored by that because it came from students. I said it on stage. I said that I'm more honored to receive an award from students than from senior members of a selection committee. And there were senior members in the front row that looked very upset that I said that. But the reason I like students is because they have a fresh mind, they're open-minded, and they really are excited about taking risks and exploring the unknown. And unfortunately, the pushback that such studies get, send a very bad message to young people. And they basically tell them you should not deviate from the beaten path. And unfortunately, if you don't deviate from the beaten path, you will never find low-hanging fruits.
Very well said. And speaking of books, you've recently written a new book. How many is that now? I couldn't get a solid number online. It's a lot.
This is my 9th book, and it's called Interstellar, and it basically discusses the impact that finding interstellar objects from a technological origin will have on humanity. So this is how it looks, the book.
It's beautiful.
Yeah, very nice.
Exactly what we discussed over the past hour.
Yeah, I gotta say, I did not fully appreciate just the magnitude of what you say and how you say it. You are an excellent storyteller. First of all, I really respect and appreciate that, because analogies are, to me, they're one of the most important ways to educate people and teach them about these complex ideas. You do a freaking fantastic job at drawing analogies on so many different things. I think it's amazing. And I did not appreciate, of course, your perspective about the whole non-human intelligence field, especially given that I have my own perspective, and I let that cloud my judgment about what you do and what you say. I was wrong. I gotta say this because I think people need to listen to your interviews, all of them, to get a full understanding of who you really are. And I'm glad that I'm a part of showing people who you really are. This conversation, I think, is more important than I would have ever imagined. So I want to thank you for.
Thank you so much. It's really a pleasure speaking with you. Another thing I wanted to mention is a story about a fisherman. There was a fisherman that claimed that all fish, he discovered the law of nature. All fish are bigger than an inch. And then someone raised his hand, and when he was making a presentation about it, and asked, what was the mesh size in your net? What was the size of the holes in your net, the fishing net? And he said 1 inch.
Exactly.
You're literally blocking yourself from finding anything beyond what you've developed a mindset for, essentially.
Exactly. So we might be blind, but we should, at the very least, we should be seeking, searching for evidence rather than saying extraordinary claims require extraordinary evidence. And I say extraordinary evidence requires extraordinary funding and effort. It's hard work. It's not as easy as having an opinion. That's why most people don't do it. But they should at least cheer when someone else is doing it. Doing the hard work is not easy. And instead of pushing back against it, they should be either waiting to see what the results are, or cheering it. And I very much hope that this will happen. I get a lot of pushback, and you can read some of it in a New York Times Magazine profile that was about my work a couple of months ago. And my approach is the same as the eagle. The eagle sometimes has a crow on its back, and the crow pecks on the neck of the eagle. And instead of fighting with the crow, the eagle just rises to greater heights where the oxygen level is low, so the crow drops off, cannot survive. And my hope is to go to the greatest heights in my profession, which is doing the scientific method, following the evidence. And to me, I'm hoping that all the crows that are pecking on my neck will drop off. Some of them are quite stubborn, I should say.
Everybody has a motivation, and especially the UFO community or people that claim to be part of such things. It's becoming very divisive, very polarized. It's almost like a boys' club on one end, and you're either of one opinion of a certain camp or you're of an opinion of another one. It's becoming a bit of a gong show, to be totally honest. We both come from different shows that were mainly in that industry and in that topic set, but we are more scientific based. And I really admire the fact that you don't stop for every barking dog along the way, as Winston Churchill said, right? You just focused on your target. You don't seek the acceptance of the popularity vote. You're just doing your thing. You don't need government help. You get your own funding, your own sensors. Like you're just going. And I think a lot of that is misguided, either jealousy or they don't fully understand. I think
exactly.
They're trying to look at you through their own spectrum of what their motivations are. And it doesn't make any sense why your behavior doesn't match what they would be doing. But you're literally doing your own thing with your own motivations. And that is where the divide is.
Yeah.
And good for you for being unapologetic. We love that. It's good to have an opinion based on something. I mean, we all have opinions, but as you said earlier, is it a bias or is it fact-based? Therein lies the small details.
Right. And I should say, I wanted to say two things. One, I really like sports. I jog every morning at sunrise. And when playing basketball, it's often said, keep your eyes on the ball. Okay. So that's what motivates me to keep my eyes on the data and the evidence, not on people. Because if you look at the audience when you play basketball, you will never win. Okay. So keep your eyes on the ball. That's advice number one that coaches always give the players. And the second thing is, we can wait for the US government to give us some information about what lies outside the solar system, but that's not their day job. And why should, the sky is not classified, the oceans are not classified. We can do it ourselves. And that's the approach that I'm taking.
So if people want to learn more about yourself or follow you, where can they go find more about Avi Loeb?
I have a regular set of essays on medium.com. So if you just search for Avi Loeb at medium.com, and you can subscribe to it with updates every few days. And it's for free. I don't charge anything. And the latest one was yesterday. Last week I had 3 of them, and so you might enjoy some of those posts. And other than that, there are all the time interviews and profiles, and there is now one being prepared by The Guardian. I just had a photographer yesterday. So there are always reports about the research that we are doing, and you can just follow them. But if you go to the medium.com postings, you might be up to date better than from reporters.
Awesome. Yeah, you are an inspiration to us. We love chatting with you. Love to have you back again. This is our new series. It is strictly a science technology based. We're not scared to go into the world of the unknown a little bit, but we want it to be a fact-based program, not based on myth and legend and lore like a lot of other programs in that realm. And it's always refreshing. And, again, we're humbled at the fact that you give us your time. You're a busy guy. I mean, you've got a list of accolades that would fill, a textbook. So really appreciate it. Love to have you back. Marquise, anything before we close out?
Absolutely. I just want to say there were so many questions I didn't get to, but with the help of AI, I'm going to have ChatGPT pretend to be you, and I'm going to have this conversation afterwards.
I would be very interested to see what the answers are.
We'll send you the results of that.
Yeah, man. Yeah.
Thank you. Because maybe I can take more vacation time if ChatGPT does better.
Get back out in that ocean and find a big chunk of that. Awesome.
Thank you. And by the way, I should say that having copies of yourself is not just a matter of, if something bad happens to me, if a car runs over me, you will have this copy of ChatGPT. It's also the fact that, in the future, if we have copies, we can let them run through our life and see the consequences of different decisions. Right. Suppose you wanted to decide whether to become a scientist or a philosopher. You can have two systems that are copies of yourself, take the two paths and see what happens. Or suppose you wanted to date a person, suppose there is a copy of that person, a copy of you, you can let those date and see if anything good comes out of that. So
there's a lot of heartache and future financial.
Take me out of the simulation. I got too many problems.
Awesome. Well, thank you again, Avi Loeb. We're going to bring this today's episode to a close. And we want to say thank you to everybody for joining us. Please subscribe to our channel. Give us a thumbs up if you like our programming. And we are on Apple, Spotify, YouTube, and the UnX network. We look forward to seeing you again next week with another fantastic interview. Again, on behalf of Marquise Williams, myself, big thanks to Avi Loeb. Thank you for joining us, and take care.